Let's take a look at example 2. Again, we're talking about the same situation that we were in example 1. Suppose the mean adult weight of a Canadian male is 82 kilograms with a standard deviation of 16 kilograms. Okay, so here you've got your mu and your sigma. Among 100 randomly selected, so n, the sample size, is 100, find the probability that the sample mean. Okay, so that's important. The sample mean is above 220 pounds. Okay, so the reason that the sample mean is important here is because we're actually talking about the average of these 100 individuals. And when you're talking about the average of an individual, or the average of a sample, then you can apply the central limit theorem. Okay, again, we saw in part A that 220 pounds converts into 100 kilograms. If you're not sure where that comes from, review video of the example 1. Okay, so let's see how this can be done. Let me start then by just drawing my normal curve. Okay, so the central limit theorem, remember the central limit theorem says that the average of a sample will always become normal as n increases. Okay, so here's the situation. Here's my normal curve. The middle is that the average of a sample will be 82, and we're looking for the probability of the average of the sample being greater than, see here the word above is giving the greater than feeling here of 100. Okay, so these are actually averages. Okay, so these are our averages of our samples. What we need to do is convert this into Z values. The middle always converts to 0 because we're talking about the standard normal, that is that the middle is 0 and the spread, the standard deviation, is 1. Here, of course, because we're talking about the average of a sample, we're doing a central limit theorem, and the formula for the central limit theorem is a slightly different than the formula for normal. Okay, so instead we've got an x bar, not just an x, but an x bar subtract mu divided by the standard deviation, which is over root n. Okay, so the two differences obviously are the x bar and this division by root n. Okay, we've already converted the middle into 0. We knew that the middle would be 0. Let's convert this value of 100 into its corresponding Z value. This will be 100. Subtract the middle here, which is 82. Divided by the standard deviation, we're told to be 16. And the number of people in this sample is 100, so we'll take the square root of 100. The value I get in my calculator when I do this is 11.25. Okay, so this value actually converts to 11.25. If we want to know the greater than probability, we can do that in a number of ways, either with our Z table or by Minitab. Okay, so the first thing, we know that we can look at our Z table. It's a cumulative Z table again. The less than or equal to sign is what the Z table gives us. We can find the greater than sign if we just use the complements. Okay, so really what we're trying to do is find this Z value here. We just calculated on our Z table. What we'd like to do is go to the row 11.2, and where it matches up with 0.05, that would be great. We could find our probability simply by doing that. Unfortunately, when we actually take a look at our Z table, okay, the largest value that we have is not, it doesn't go up as high as 11.2. The highest value that we have is actually 3.4, and where the largest value that it goes up to is 3.49. Okay, which gives us a value that's very close to 1. Although we don't have an 11 on this table, we can use our imagination. We can see the trends that are building. We see that we're getting closer and closer to 1. If 3.49 is almost 1, then you can almost be very sure that 11.25 will be very close to 1. Okay, so unfortunately, although we can't see it on our table, we know that the cumulative probability of a z value of 11.25 will be very close or approximately 1 or 100%. Okay, so that is the cumulative probability. Okay, we can actually find the probability of the greater than by just finding the complement. Okay, so 1 minus the probability of our cumulative probability will give us our greater than probability. Okay, so 1 subtract the cumulative probability, which we found to be approximately 1. 1 subtract 1 is 0. What we're actually saying here is the probability that the average of a sample being greater than 100 kilograms is pretty much 0. Okay, so pretty much 0 chance of that actually happening. Of course, we can do this in Minitab. Let me show you that really quickly. Calculate a probability distribution. Here, of course, we've got a few options. We can do the standard normal option. That's where the middle is 0, and the standard deviation is 1, and we're trying to find the cumulative probability of our z value that we have calculated to be 11.25. Okay, we didn't know exactly what this was, but we thought that it would be very close to 1 just using the table and using our information about the standard normal table. Okay, here you can see Minitab is also